Hello, I'm Gerald. You are? And you are?
John.
Very good. Hi, John. Hi, Grum. My talk is preposterously titled Precision Munitions for Denial of Service. Okay, besides, stop working. So, I'm old and grumpy. I remember Java 1.0, coded in it. I was amazed by Java 1.1. I've had a long career of developing software, making software. I won't bore you through all the details, and it's led me to finding problems, breaking software, and now I do it sort of professionally. I'm the AppSec lead for HMRC Digital. But I've got many hats. So this talk is about denial of service, but not the distributed kind. I'm not interested in a lot of bots overwhelming your website. So precision strikes over carpet bombing. I'm going to use the play framework as an example, mainly because I work with it, found some problems with it. Then I'm going to talk through something I called automatic amplification, and maybe some lessons and what we can do to prevent it. So, like I said, it's denial of service, not distributed denial of service. So I'm not the low-orbit iron cannon of anonymous fame. I'm not this Imperial Starfleet just firing lots of things at things and hoping that stuff breaks. It's all about being small, targeted, precise, having a massive effect. So, to do that, I'll sort of jump in, and don't worry, the Star Wars metaphors will stop soon. But if we have modern infrastructure, typically your service is behind a number of layers of infrastructure. You've got your content delivery networks, you've got your web application firewalls, you've got your load balancers, and all of those, essentially you have to navigate in order to deliver a denial of service attack. And a lot of these bits of infrastructure are precisely designed to stop lots of brute force and ignorance from getting through. Now, this is the vulnerability that I found, and it's quite an interesting one, because when I send a JSON payload, which is what you see in the little thing here, which is a valid piece of JSON, but I just have an array inside an array, inside an array, inside an array, and I've got about 30,000 open square brackets and 30,000 closing square brackets. And what happened was that this payload, when that got passed by the play framework, which is an application framework, it blew up. Because the way that it was passing was not clever enough to sort of say, yeah, if you have a nested array and an array and an array of like 30,000 things, it's not really ideal. So I took that and I found locally, when I tried it out and was playing with it blew up the system. The application instance just crashed and stopped. It's quite an efficient way of denial of service if you can shut somebody's service down. Now, if we think back to the modern infrastructure, usually you don't have just a single instance running. And this is where this comes into effect. So when I put my payload and deployed it against an actual test system, which was on test infrastructure, which had got the CDN, the web application firewall, the load balancers in front of it, what happened is I blew up 3 instead of 1 by sending a single payload. And what happens is that the load balancer goes and says, right, I'm going to send that payload to the application. The application blows up. and returns an HTTP 503, which basically means some things went wrong. And in this case, the load balancer by default was configured to say, well, this is something went horribly wrong, so I'm just going to send the request to another instance of the application. Blew that up. And then the next one. And then it kind of went, yeah, all right, I'm going to give up. But it's a single request that blows up 3 application instances. So that's quite cool. So then I thought, well, does it actually matter? A single request blowing up 3 instances. Typically we run in Kubernetes clusters or cloud infrastructure, and that kind of stuff is self-healing. Something blows up, it spins up another instance. If that blows up, it spins up another instance. We've got, self-healing infrastructure, we've got automatic restarts, we've got auto-scaling groups. But the interesting thing is, those bringing up another instance isn't an instant thing. It takes a little while. You have to provision a new bit of a container has to be deployed, and it has to come up. Now, where I was, that sort of took a minute. And you also have to think that a container is not always detected to be non-functioning straight away. Typically what you've got is you send sort of little pings, and if 3 of them fail in a row, then it goes, yeah, that's dead. I'm going to replace it. And what I then did, I wrote this little bash script, which just basically sends 50 requests, 1 every 10 seconds. And if you think that each one of those requests takes down 3 instances, over a minute I can kill 150 instances, which typically you don't have that many instances, and I can bring instances down quicker than you can bring them back up again. So it's a game of whack-a-mole. So infrastructure isn't going to help us here. But what about the WAF? Surely if I've got a malicious payload like that, I can protect myself against it. Well, one of the things about WAFs is they need to inspect every request. And in order to do that, they've only got a limited amount of computational power. So what they tend to do is... Come in. What they tend to do... Yes, please sit down. What they tend to do is they take only the first few kilobytes. I think in AWS, by default, it's the first 8 kilobytes. In Akamai, it's the first 16 kilobytes. And look at the first thing, and the rest of the request is not inspected. So if I modify my malicious payload and take that JSON and put an innocuous looking string that's about 8 kilobytes or 16 kilobytes long at the front of it, and then have my malicious JSON, it'll go straight past the WAF. So I'm not saying that a WAF is something that is not...
Sorry.
It's all right. So I'm not saying that a web application firewall is something that won't help, but it won't help on its own. It's a nice layer of defense. So, going back, the sort of vulnerability that I found got its CVE, it got assigned a CVSS score, and obviously, we're all running proper dependency scanners, and we're all looking at all of the CVEs that are being... no, we're not. The scale of looking at every single CVE is a bit of a problem. And the fact is, because it's a denial of service vulnerability, the maximum CVSS score that it can get is 7.5 on a scale of 0 to 10. And a lot of the dependency scanners that sort of purport to say, well, we do coding that's secure by design, they sort of advocate for sort of saying, okay, well, we know that there are lots of vulnerabilities and you can't look at all of them. So how about you put in a policy to say that your build gets broken if there's a vulnerability of score higher than 8? Well, that'll get through. So the question is, as a defender, do you look at every single CVE? Now, that was one example. There are other fun examples. And this was one that I quite liked. Now, this is an XML vulnerability, and it allows the remote attacker to cause a denial of service via crafted messages, and that's what a message looks like. You basically send through lots of XML tags that all turn out to be the same hash code, which then means that underlying the processing, it kind of uses more and more and more time to process this. And if you make this request big enough, say approaching a megabyte, then you can kill something quite efficiently. And the interesting thing was, so this is a vulnerability from the year 2012. So, more than 10 years ago. And then you look at how many things still use it. And there's so this was the vulnerable version. And then if you look at the number of downloads, lots of software still uses that old thing, because this had a rating of 7.5 again. So lots of people kind of go, I'm not too worried about that. But remember, if you can kill somebody's instances, if you can completely deny, let's say, your login service, and nobody can log into your system anymore, well, it may be something to look at. So this is what the CPU usage looked like by sending 10 of those malicious hash collisions. It just eats up the thing. And if I keep sending it, a relatively low volume can kill the service. Now, there are other fun things in there. There is things like a YAML bomb, or the billion laugh attack, or zip bombs, or probably one of my favorites, the regular expression denial of service. The reason why they're one of my favorites is because regular expression denial of service usually gets assigned a score like 5.3, so way down, and a lot of people just don't look at it. But the impact can be the same thing. If you can deny a system from running for long enough, then the infrastructure will go, oh, that's dead, because the pings that are being made will no longer respond in time, so the instance will get killed. Now, the other problem is a problem of scale. Typically, when you've got services, you don't have 1 or 2 or 3 or 20 services. You've got hundreds or thousands of services. Now, this is a intentionally badly drawn diagram of some infrastructure that I'm working with at a well-known tax collecting agency of the UK, which shall remain nameless, HMRC. And these are all the systems that talk to each other. And this is only in like the front end bit. Now, all of these have got potential vulnerabilities in their dependency chain. And that's what makes it tricky. Can you actually look at all of them? If you maybe think of your organizations or places that you know of, is it feasible to look at all of those vulnerabilities and mitigate them all? So when I did that at the said unnamed tax agency, the first time I ran a vulnerability scan, it came back with 836,486 results. So these, of course, were a lot of the same ones, but a lot of the problem is that things depend on context. When there's something that's a vulnerability, And it said, for example, an XML one. Well, if I don't use XML, then I can ignore that. But am I really going to be able to look at all of those? And I've come to the conclusion that, unfortunately, the answer will have to be yes, because in order to assess whether something is vulnerable or not, the only way that you can do is eyeball it, can say, well, how is the particular thing being used? Now, what helps if the services that you deploy are sort of using this idea of a paved road? I think that term was initially coined in sort of Netflix, and essentially the idea is that you put in ways that you build your services that are fairly opinionated and follow the same patterns, so that rather than having 5 different languages and 20 different frameworks in a plethora of sort of services, you'd never be able to get a handle on what kind of denial of service vulnerabilities are hiding there. But if you have an opinionated platform, a way of building services that is fairly consistent, then I think you've got a chance. And I've got no idea how we're doing for time. Lots, okay. So that's what I ended up doing. And one of the most fun things is, as a developer, as a security person, I found that my favorite tool are spreadsheets. Essentially, to have those 800,000 things, I couldn't look at them all, obviously. But if I build myself a pipeline that sort of looks at, well, what are the common ones, how are they being used, where they're being used, and create a big spreadsheet, I have a chance to actually look at all of them. And that's what I ended up doing. I think in the last year, I looked at about 700 vulnerabilities, assessed them, and checked how they would fit in. And the interesting thing is, a great many of them were just out of scope, were just not applicable. A great many of the ones with sexy CVE scores as well, the ones that have got 9.8, and I looked at it and, okay, we're not using it in that way, so I can ignore it. I don't have to update that dependency, which is all right. I could just keep all dependencies up to date. If I had 10 services or 20, but if I'm talking 1,000 services, that becomes more and more complicated. Yes, maybe I'm not the best at graphic design, but so what we do at said unnamed UK tax collecting agency is we've come to the realization that application security, or a security team, and the team that is developing services, they can't do the job on their own. There's no security team big enough that can go around an organization, fix all the problems, or analyze all the problems. So it needs cooperation. And it's one of my other passions. One is AppSec, obviously, that's why I'm here talking. The other one is agile software development. And I think that's where AppSec, if it turns agile, which means that you look at collaborating with people, that you look at fast feedback loops, that you look at iterating, makes a difference here. And that's where I think a security team can specialize into analyzing vulnerabilities, making recommendations. The service teams can provide context and fix the issues and, ask questions. So that's, I think, a lot of legwork. It's one thing where AI won't save us. But working together is the way out of the denial of service. So I'm quite aware that most people have missed the first third of the talk. So I don't know whether you want me to go back a bit or whether I'll just finish up. Dealer's choice. Okay.
Still your choice.
I might just go back and just say that this was the attack initially. The idea was that this is a valid JSON payload. It's got an array and an array and an array and an array. If I've got 30,000 open brackets, 30,000 closing brackets, I can blow up a single system. Modern infrastructure can amplify this, so rather than blowing up one system, the load balancer will resend a request, which then engages in a giant game of whack-a-mole. And that's how you can deny a service quite efficiently. So back to the lessons. I think far too often denial of service is not taken seriously enough, because it's like, well, I can't achieve remote code execution, so why should I worry about it? But we spend a huge amount of money throwing it at web application firewalls, throwing it at DDoS protection to protect us from denial of service. And I think we need to do the same thing for those precision strikes, for those targeted denial of service attacks, which I think will mean that we'll have to look at all of our vulnerabilities in order to sort of get a clear picture of what's vulnerable. Scale is always a problem, and the solution, I think, is mainly collaboration, making sure that a security team knows what the developer's doing, and the developers know what the security team is doing, that there isn't like you don't want a development process where the gods in the ivory security tower come down right at the end of the life cycle and say, no, you have got a vulnerability, you can't go to production. And then they go, yeah, but we need to because there's a deadline and we'll just sign off the risk. A paved road and layered defenses are also something really useful. And that brings me to the end of my talk that I've given 1.5 times. I'm very happy to give the talk again and again and again outside, and I'll talk you through it. Other than that, any questions?
For the CV that you found,
yeah,
was there anything that would have helped prevent it? So, let's say I'm using that framework at the minute, updated it. What, if anything, could help mitigate it?
So the interesting thing was, and I probably should have mentioned this, the interesting thing when using that framework was that the processing happened before it even reaches your own code. And the framework had some logic in there to sort of say, depending on what content type to send, if I don't process JSON and I'm expecting form-encoded URLs, I try to convert between the two. So the problem was that there was a website that accepts post requests of forms, and you send it JSON, and the framework goes away and says, oh, I'm going to try to convert this. Oh, and there looks to be an array, and that's when it sort of started to blow up, because it tried to convert that JSON into a query parameter name. So it is about this idea of being aware of what content types you accept, because if you put some logic in your load balancer or your CDN to say, I don't want to deal with JSON requests, then that would protect you because for that particular thing. But it's always difficult because there's so many different variations.
What was the back end to it in it?
It's play framework.
Oh, understood. So is that its own sort of language of sorts, or is that just a framework?
It's Scala.
Oh, understood. Okay.
Play framework is Scala, yes.
Got it.
Which is a JVM based thing.
Got it.
Any other questions? Brilliant. Well, John and Drum, I introduced myself personally for two people, so I hope to catch up with all of you in a bit.